fourth and hopefully last video on lesson 4.1. And we're still doing solving systems of equations. We've already done graphing. We've done substitution. Now we're going to do elimination. And I've got 6 examples to do, and hopefully I can get them done in the amount of time. Elimination is not the hardest at all, as long as your x's are lined up, your y's are lined up, and your constants are lined up. So because of that, we usually want it in a standard form, but there is an exception. If you have a negative on the front, it's not such a big deal when we're doing this, so you don't have to worry about getting rid of the negative on the front. If it has fractions, we are going to get rid of the fractions. It makes it difficult to work the problem if you've got a bunch of fractions in it. Okay, so here we go. Number 24. If we were doing a substitution, we would have had to solve this thing for x or y, and we'd end up with a bunch of fractions, and things would have been complicated. But in elimination, what we're going to try to do is on either the x or on the y, we're going to try to get additive inverses for the coefficients, meaning that, like this is 6, I would want a negative 6 here. That way when I combine these together, they'll cancel. We're actually kind of lucky on this problem because it already has positive 2x and negative 2x. And because those two are additive inverses, we can go ahead and combine these. Negative 2x and positive 2x is 0. 3y, 6y makes 9y. And y is 1/3. Now something that makes this a little bit worse than substitution is that I don't have an equation that's solved for x for me to plug this into and, you know, find out what x is. But that's alright, we'll work around it. Choose one of these to plug into. I think I'm going to plug into the second equation that doesn't have negatives. Six times 1 is 6 divided by 3 is 2. So the ordered pair that makes that one true is 1/2, 1/3. See, graphing would not have been a good choice for that, because if we had graphed, it'd be really hard to tell exactly where 1/2, 1/3 was. More than likely, we would have thought it was 1/2, 1/2, or who knows what we would have thought it was. It wouldn't have been on grid points. All right, 26. Okay, I think what I'm going to do is, it's kind of like when you're doing fractions and you get a common denominator. We're trying to find a common multiple that both these will go into, or both the x's. I think I'll do the x's this time. So, what we do is we're going to multiply this. A common denominator, or a common multiple for 6 and 4 would be 12. I'd have to multiply this one by 2 and this one by 3 to get 12. That's going to give me 12x on both of these. Now, I need them to be additive inverses, so they need to have different signs. So I'm going to put a negative on one of them, just so that now I'll have different signs. Multiply this across. The 12x minus 12x cancel. Oh, this is negative 28, not 18. Didn't see the negative up here. Alright, and y is going to be negative 7. Now I know what y is. To find x, I'll just plug it into one of these. Doesn't really matter which one. I think I'll use this one. Make sure that you pay close attention to signs here. Minus y would be minus negative 7. It's kind of depressing sometimes how one little sign change, one little sign slip up can cause your problem to be wrong. X is negative 2, y is negative 7. Okay, on the next problem, like I said, I would recommend that we get rid of the fractions before we start trying to actually we already have additive inverses here, but we'd have to combine these together. Let's just go ahead and get rid of the fractions like I planned. We'll run them side by side so I'll have room to work on both of them. Okay, common denominator is 12. On this it's 8. Uh, 12 times 2 is 24, divided by 3 is 8x. 4 goes into 12, 3 times 1 is 3y. So see, you can either multiply by the top and divide by the bottom, or you can divide by the bottom and then multiply by the top. It's get you the same answer, because 12 times 1 is 12, divided by 4 is 3. I think I'm going to divide first. 2 into 12 is 6, times negative 3 is negative 18. Okay, I'll go ahead and do this one while I'm at it. 2 into 8 is 4, times 1x is 4x. 4 into negative 8 is negative 2, times 1 is negative 2y. It's negative 16. Okay, now I'm going to stack these. So I can combine them. And so I can figure out what I'm going to multiply by. I already have different signs on the y's, so I think I'm going to get rid of the y's. Okay, I'm going to eliminate the y's. A common multiple for 3 and 2 is 6. So to get 6 right here, I'd have times this by 2, this by 3. That will make this positive 6, and this will be negative 6. So that will work. That'll work out good for my additive inverses. I'll go ahead and do the multiplying. This can be kind of a long process, and because of that, maybe this is why this method isn't used a lot. 28x is equal to negative 84. You may be thinking gloom and despair here, but I think that will go in evenly. Yes, okay. Okay, now I need to find an equation to plug this into. And the neat thing is, I can use any equation that we've had here. So if I wanted to use this one, I could use it. I could use this. I could use this or this. I think I'll use this one here just because there's some empty space below it, and it looks a little less complicated than some of the others. Well, it does have a negative right here. Yeah, I'll go ahead and use it. 4 times -3 minus 2y is equal to, see how I substituted -3 into x right up here. This has got a lot of negative. Oh, it's working out nicely though. Answer's -3, 2. And it looks like I've run out of time.